Hello everyone, this is Dheeraj. So this is a continuation part of the previous video about routing. So we have already discussed about these slides which are just shown here. So we discussed about this about these layers, and then we discussed about a scenario where you have a PC and connected to router, and then we discussed about a scenario about when you are trying to access a Google DNS server. So how would your routing table comes into picture, and how the decision has been taken by routing. And we also discuss about this arc table, how does the MAC address picks up when the next hop is chosen by the routing. So we will discuss about more in detail about this routing, and also I will try to show how the decision is taken like practically. So let's jump into the conclusion of this. So this is my Linux machine I have currently. This is a Ubuntu 16. So as you can see, it is connected uh, via this network. So ETS0 is its default interface via which I communicate to the internet. So this is the IP address. This is a local IP which is given by a DHCP server which is running on my host machine. And if you see this window, this is my default host machine. And for my host machine, the EN0 interface is the default interface to communicate towards the internet. And this 109 is the IP address which is given to this machine via the router. Okay. Now, when I try to ping this, as you can see, it will only work via this ETS0 interface. It is going because it's the only interface which is open to the internet. So how do we make sure so let's try to capture the packets. Okay, let's try to capture it. Okay, now let's run it in background, and we'll try to ping it. So so I sent around 3 packets, and let's try to stop it. Okay, so these packets has been reached here. Now I will just copy it in my host machine. Okay, so I copied this packet capture in my host machine, so I can easily show you guys on Wireshark. So I have this Wireshark window opened. Okay, let's try to open that packet. Okay, so it would be in my home around documents. Okay, let me just provide the permission for that. It would be here. Okay, this is the packet capture on the machine. Now, as you can see, let's analyze this packet capture. So if you are not aware of this tool, Wireshark, so I have already made a video about the overview of this tool. So you can just check it out. I will put the link in the description. So here, this is my IP address, right? So let me just put this side by side. All right. So as you can see in the right side, so this is my host machine's IP address. So the source is this, and we are trying to access. So these are the TCP packets. So let's filter it out with the ping. So ping is a ICMP. Now here you can see this is the first packet, 87 number. So C10.0.2.15, the destination goes to the 8.8. Okay, this is the ping request packet. All right. Now, as you can see here in the MAC header, okay, uh, how does it choose this MAC address, right, as a destination 35.02? So for the source address, it makes sense because it just picks it from here. As you can see, source address is ether address. As you can see in the left side, 27.pv or 1475. As you can see, this is the source MAC address. So the main question, why routing comes into pictures, like how you choose the next hop. Okay, as I've explained in my previous video as well. So how do you choose the next hop? Okay, that's where the routing comes into picture. So let's see the routing table. So this is how you can print the routing table with the kernel IP routing table. Okay, so there are many commands to see different view of this table. This is one of them, route -n, and there is one more, IP route show, and there is one more which is similar to this routing, but it can it prints the same table via other command as well. Okay, So it shows few of the extra information like MSS and IRTT, but other than that, the most of the information is same. Okay. So basically, what this routing table does here, as you can see, when it tries to find the route for this 8.8 network, it was not able to. And I explained earlier, so this is my default route here. And other than that, there is a one more route with 10.0.2.0, and the one more field was their gateway, which I did not explain in my previous video. So the main idea of the gateway is like how would you choose the next hop, right? So in this you have this like network address. This is a network address, right? So once your destination address, when it is get masked with this gen mask, you would find the destination address, right? So if you found the same destination address, then you choose this gateway as your next hop. So in this, what is your gateway? Like 10.0, and for 10.0, you go to this destination and you find that what is your gateway. So gateway is 10.0.2. Okay, so if I do r-a, so this is r table. Okay, let's do r-n. It's a more nicer view. So here you can see I have a gateway address, right? So this is a MAC address. This is my gateway, which is the same machine which I'm running on my host machine. So this is DSCP server running there. So this is 35.02 is a gateway for me. Okay, so that's how it came. This destination address as 35.02. Okay, so this is how routing decision has been taken. So if you let me just brief it one more time. So basically you try to ping this 808 network, and when it goes from this machine at the layer 3, it tries to search the route for that particular destination. Okay, if it tries to find here and it did not find with the 8.8 dot 8.0 because it and did the AND operation with this 255. Okay, and if it did not find the destination address here, so what it does, it chooses this default address. So it goes through the whole routing table, and then it chooses this default route. Okay, then it goes to this gateway and it tries to find the MAC address of this gateway, but it won't put the next hop, it won't put the destination address to this one. Okay, as you can see, the destination is still 8.0, right? 8.8. Okay, so it just uses this routing table to find out the next hop, next connected hop, so that it can send the packet to that hop. And on that machine also the same logic will happen. Okay, on that machine also again routing will happen, and it will try to find its next hop, right? That machine's. So in my case, as you can see here, so 10.02 was my machine's my machine is acting as a gateway, my host machine. So this is a VM inside a VM, and then it chooses the MAC address from this ARP table. Okay, this is address resolution protocol. I have already explained about this protocol. You got wish to like watch that video, I will put the link in the description. So this is the MAC address it chosen, so that is why it put the next hop as a this MAC address. Okay, as you can see here in this packet capture as well. All right, so that's all I wanted to show here about the routing table. So there are a few more bonus things I want to point out in this routing. Okay, let me all right. So when I explained this routing table, right, so there are a few catches here. So let's say if you have multiple routes. Okay, let's say you are trying to reach to this network. Let's say you have route for this. Okay, like that. uh, Now this is a mask. So there is a mask which tells that how big is this network. Okay, now mask is basically in this case let's say 255.255.255.0. So it means that it's a 24-bit mask, right? But what if we have this again one more network, but the mask is the network is bigger. Okay, like that. So this will also fall here, right? If you're trying to send to packet to 168.0.5, let's say. So what will happen if it goes to this routing table? Okay, then it takes this IP address, it takes this mask, do the AND operation, and if it finds this will also. So in this case, if you see, both will be the same, right? If it does the AND for this with the 255, this 24-bit mask, it would also find this first network address, right? And if you also end with the instead of 254 of 24-bit mask, it does with the 16-bit mask. Okay, if you do the 16-bit mask again, you will find that the same network address. Now, how will you choose out of these both? So these are both same, right? How will it pick the next hop if both the things are there? Let's say you have interface with this, which is a different interface. Then how would you send to which interface, right? So this is a conflict here, right? So how does this routing table works if there is a two routes with the same? So it uses a algorithm which is called LPM. So LPM is the longest prefix match. Okay. Yeah, so basically routing chooses this longest LPM algorithm, longest prefix match. So how does this longest prefix match works? So it tries to map with all the entries which are similar. So let's say there is one more entry with 192.168.0.0 and the mask is even bigger, like even bigger network address, okay? And there is an interface of EN2, let's say. So it would still come to the same, right? So all the three matches with this destination address. So how would it pick the first one? So it uses this longest prefix match. So what it does, it tries to find which is the longest matched with this. So longest means like which is more near to this this destination. So how would it find out? So you can say that if you mask with let's say 255.0.0.0, then you are sure that you are only masking this number, this first byte. Other than that, you are keeping it open, right? So even though it is same, but it is not the longest one, right? It is not more near to this. But if you choose the first one, 255.0, then you are definitely know that this is the longest matched. So the longest matched basically means the more the net mask, the more bits you are masking, the more you are near to this net destination, right? So in this, with this algorithm, longest prefix match, it would choose this EN0 as a destination, not the other ones, because as the longest bit masks, so this 255, 255, and 255, 3 are the like more inclined towards this destination address. Okay, so this is how routing works in detail about in algorithmic level. So we will also discuss in routing somewhere in between our course about how this is implemented, how the which data structure is used. Okay, so I would just point out to one thing. So this routing table basically is implemented with the help of a trie data structure. So you can look it out about the trie. Otherwise, we'll also discuss in the course. So that's all I wanted to talk about routing in this video. Thank you guys for watching. Stay tuned for the next one. Bye bye.